Hello and good day to Miss Boon, Lily, and all of my friends. I hope all of you are in good healthy conditions. So today, me and my team will present about the application of linear algebra in electric circuits. The main content of our presentation is there are three main contents of our presentation, which is what is Ohm law, second, how to implement system linear algebra method by use in electric circuit, third, what is conclusion of our case study. Ohm's law is a simple and useful formula for analyzing circuit that developed by Josh Simon Ohm law, which is a physician from German, and by his study he have produced a formula which is V equal to IR. V representing for voltage, I representing for current, R representing for resistance. We proceed to our problem statement. So, as you can see our slide, this is a circuit which have been assigned, have been divided into four. Circuit 1, circuit 2, circuit 3, and circuit 4. Why we must divide the circuit into four? So it will be easier to position the value of resistance in matrices. Later we'll present in method.
I am Muhammad AINUDDIN bin MAHLI from CS 1105D class. So for our project objective, it is to study the application of linear algebra in electrical circuit, and it also to solve electrical circuit parameter, and the last one is to find the voltage, resistance, and the current in the electrical circuit.
Hello and good morning to our lecturer, Miss Boon, and our fellow friends. I am AIMAN, and today I'm going to continue to present about methodology. Methodology. First step, assign mesh current. To assign the mesh current, we need to identify the available mesh. In this problem, there are 4 mesh current that can be assigned, which is current 1 between 2 ohm and 5 ohm, current 2 between 3 ohm, 5 ohm and 6 ohm, current 3 between 8 ohm, 3 ohm and 2 ohm, and lastly current 4 between 6 and 7 ohm. Now, all those current available, which is current 1, 2, 3, 4, can be put inside a 4 times 1 matrix. Second step is to find the resistance matrix element. RII equal to total of R mesh. R11 equal to 2 ohm plus 5 ohm equal to 7 ohm. R22 equal to 3 ohm plus 5 ohm plus 6 ohm equal to 14 ohm. R33 equal to 8 ohm plus 2 ohm plus 3 ohm equal to 13 ohm. And R44 equal to 6 ohm plus 7 ohm equal to 13 ohm. From this result, those numbers can be assigned to 4 times 4 matrix, resulting it to become like shown above. Secondly, we need to find resistance matrix element using Rij equal to negative R shared by I and j. R12 and R21 equal to negative 5, R13 and R31 equal to negative 2, R14 and R41 equal to 0, R23 and R32 equal to negative 3, R24 and R42 equal to negative 6, and R34 and R43 equal to 0. After all those numbers have been gained, it can be now assigned to the 4 by 4 matrix following the first step according to Rij in the matrix as shown above. And lastly, to find the mesh voltage. To find the mesh voltage, The voltage from each mesh must be on the same direction of the current. From positive of power sources to the negative need to be calculated based on diagram. Voltage have negative value because of it travels from positive terminal to negative terminal. Based on the diagram, we can conclude that mesh of voltage current 1 is 20. Mesh of voltage current 2 is negative 30. Mesh voltage of current 3 is equal to 0. And mesh voltage of current 4 is equal to 6. After all those steps has been done, this equation will be gained.
Hello, I'm Macallister, and today I will be explaining on the result that we get for our case study. So the figure shows that it is an equation that has been obtained by ASYRAF from the previous methodology. So we will be using this augmented matrix or equation to find the current here, which is I1, I2, I3, and I4 by using Gaussian elimination method. So our main job here is to make sure the first number here is 1 and the rest here is 1 as well diagonally, and the number below it must be 0, which is this -5, -2, -3, -6, and here is already 0. So the first step is to make the first number equal to 1 by multiplying 1 over 7 into the first row. So we'll get 1, -5 over 7, -2 over 7, 0, and 20 over 7. So next we'll be making the number below here, which is -5 and -2 into 0. So in order to do that, we'll be multiplying the first row with 5 and then adding all of the numbers of the first row with the second row into the second row to replace it, and then multiplying the first row with 2, and then the number that has been multiplied will be adding with row 3 to replace it into row 3 to get this. So next we'll so the next the 3 number here is already 0, and we need to make sure that the second row here, the number here, is equal to 1 as well, since all the number needs to be 1 constant diagonally. So we'll be using 7 over 73 multiply with row 2 to replace it into row 2. So next we will be using 6 multiplying with row 2 and adding the numbers with row 4 to replace it with row 4. So we will get 0, and next 31 over 7 multiplying with row 2 plus row 3, then replace it with row 3. And the step goes on till we get all of it into 1 diagonally and the numbers below it to 0. So once done, once the metric has been reduced, the data here that we obtain will be used to find the current of each section of the circuit, which is I1, I2, I3, and I4, also known as current 1, current 2, current 3, and current 4. So we'll be solving it backwards because we have it is the current for the fourth section has already been obtained, which is negative 1260 over 3439. So the current is a negative because the current is flowing against the opposite direction. So to obtain the current tree, we'll be using the current flow that have been obtained here. So from here, negative 1/11 from the row tree, we'll be subtracting it with negative 93/385 and times it with current 4 to get current 3. To obtain current 2, we'll be using the second row, which is negative 510/73 minus negative 31/73, which is this one, times by the current 3 that we have been obtained, which is negative 0.1794, minus negative 42/73, which is this one, and the current that we have been obtained for current 4 to get the current 2, which is negative 1.3722. So the same goes to current 1. We'll be using the data that we have, the current that we have been obtained for current 2, current 3, and current 4. We'll be subtracting it to get current 1, which is negative 20/7. This one, minus negative 5/7, minus current 2, then minus negative 2/7, and then the current for current 3 to get 1.928, which is the answer for the current one. It is in positive because it is flowing in the right direction. Thank you.
For a conclusion, algebra method can be tools in many things. It also part in our life society. And it is something that can be used to help us to find conclusion in any problem that involves algebra, such as electrical circuit, which is to calculate the current flow through electrical circuit using algebra method, and various electrical circuit solutions such as Ohm's law are related to linear algebra. With the help of linear algebra, Kirchhoff's voltage law, Ohm's law, and also Gauge elimination method can easily solve for the value of the unknown variable within a circuit. Thank you.